Hey everyone, I'm Stas, welcome to my YouTube channel, and today we're going to take a look and get started with this AI Accelerator card from Tenstorrent. Currently I have this N150, just take a look at it. Just look at this beautiful texture. This card also comes with active cooling kit out of the box, which looks roughly like this. You're supposed to connect it to this N150 card, so it provides the steady stream of cool air, so the card doesn't overheat. The original fan which comes in the box is kind of loud, so I highly recommend replacing it with this one. I'll provide the link in the description. So let's get started. So the first step of the installation process is to mount active cooling kit onto the card itself. It's done with a few screws and it's really straightforward. So it would look roughly like this. After it, we should install it in our PC. But before we do that, please keep in mind, the card comes with this notice in the box, which says that we must use 4+4 pin connector to connect the card. Please make sure that your power supply actually has one of those available. And you would additionally need another 6+2 pin to connect the included fan. Or if you're using a custom fan that I recommend, you need another fan socket on your motherboard. So let's go install it. I already performed the install on my home PC. As you can see here, I put a Tenstorrent card right underneath my RTX 4090, and compared with the card is actually quite small. And as you can see, there is a green LED showing that everything is installed correctly. So let's go and install the software. So here I'm SSH'd into my home PC, which is running a fresh install of Ubuntu 22.04. To get our card set up, first we go to Tenstorrent official website, then we click on support and go to documentation site. Okay, now we scroll down, go to software installation. As you can see, the first step is to install the TT-KMD, which is the Linux kernel mount driver. Okay, then let's open the link. We get to GitHub, we scroll down, installation instructions for Ubuntu. Copy this command, paste it here, add sudo, enter password, and agree, I guess. Okay, this one installed without problems. Now I guess we need to clone the repo. Let's clone the repo. Git clone link. And it's cloned. Cd to the folder. Oops. Then we go sudo dkms enter. Sudo dkms install. It's thinking. And sudo. And I guess that's it. Okay, let's go to step 2. It says that we need to update the firmware. And here it says go to the Flash homepage. Let's go and let's go step by step. Getting started. We need to install Rust. Okay, let's install Rust. Copy commands here. Agree. Downloading some files and update the source. Hopefully it's installed. Next it says do the virtual environment. Okay, in this case, okay, let's proceed the instructions. It says I don't have Python. Okay, Python 3. It says I need to install something. Okay, let's install something. Create virtual environment. Activate virtual environment. and then do pip install. And it's building. Build. Okay, to build from Git, I don't think we're building from Git. Oh, typical usage. TT flash, FTR and the file. But we need to get the firmware file first. And here it says that the firmware is in separate repo. Let's go here, and here is the file. Open this, and I need to download this on my machine. So I copy link, go to here, we get link, and the link is here. Okay, let's go back and try installing it. Flash, and our file, fpack bundle. Let's wait a little bit. It says flash success. So we completed our step 2. Wonderful. Let's go to step 3. It says update and install the get-git. I think we already have those. Now it says git clone TT system tools. Oh well, let's clone it. Go to directory. Execute commands one by one. It's a complete huge page setup. Okay. We get install some files. System still enable. Seems strange, but oh well. Enable another one and do a reboot. Okay, let's wait for our PC to reboot, and hopefully we should be done with this step. So our reboot is complete. We can SSH back into the machine. Yep. And let's proceed to the next step. It says install system management interface, TSMI. Go to the home page. Okay, let's go here, and here it says management interface, getting started, building from Git. Install source Rust for the Leuven library. We already installed Rust. Now create a virtual environment, already done that, and then install TSMI like this. Okay, it means we need to clone the repo first. So we type git clone, navigate to TSMI, and do pip3. Oh, we need to activate our environment first, then navigate to TSMI, and then do pip3 install. It seems like it's installed. Now it has usage. Okay, if we just run TSMI, it should show us the UI, checking if everything works okay. So we run TSMI, yeah, and we do indeed see this beautiful UI. It shows our hardware stats, everything is green, everything is passing, and it sees our single device. It shows we have our DRAM speed, link width. I can even click in the UI, it shows my telemetry, the power, temperature, firmware versions. Everything seems to be okay and working. So let's quit it and continue with the next steps of the installation. Okay, let's go to step 5. It says optional multi-card configuration, but I only have a single card, so I'm gonna skip this one. Verify system configuration. We already did this one. And now we need to install the SDK. Okay, let's go to step 7, SDK installation. In this tutorial, we are going to install TT-Metallium /TT-NN. This SDK provides both low-level C++ APIs and high-level Python APIs, which should be easy to run some models. If you scroll to README, it already shows that it supports a bunch of LLMs, CNNs, NLPs, and just a lot of stuff. Low-level guides on how to develop for the platform. Okay, how do we install this? Okay, it says install. Installation steps. Driver and firmware, we already done this. Okay, it seems like we need to clone the repo first, obviously. So we clone the repo. And then we should run install dependencies sh. Hopefully it should work. And it's installing a lot of dependencies. Okay, it failed to install Python 3.8 and when hopefully it's not important. Okay, then it says set up huge pages. Interesting. I think we already set up huge pages. Should I run it again? It's unclear. But, well, just to be safe, let's do it again. Those instructions seem to be a bit different. Just run through steps. Run a reboot. And while the reboot is running, my cat decided to join me. You can take a look at this cat. Okay, PC is back up, so we SSH back into my PC and do a second step. Oh, and it fails because I actually was in a different folder. Let's try again. Passed. Okay. Let's install git LFS. Okay. Clone the repo. But we already cloned the repo. Oh well. Go to a folder, update all of the submodules. Most likely we need to do git submodule update -- init -- recursive. Okay, now we can do this thing, download all of the large files, and it's downloading. Okay, everything is downloaded. Option 1 from source. Okay, it says to set some environment variables. But actually what we're going to do, instead of setting them in line, we're going to set it in bashrc file. So they're preserved every time, even if we reboot our PC. So we go to bashrc. Let's add some lines. export arch name equals. Arch name is one of, currently this card is a Wormhole B0, so put Wormhole B0 here, TT-Metal home, we cloned it into home stas TT-Metal, and Python path should be the same. Okay, hopefully this is it. So I reload my bashrc file. Then I simply call build metal. Let's hope it works. And it says cmake command not found. Okay, let's install cmake. And then try again. Now it says there is no Ninja. Let's install Ninja. Ninja build. Try again. And now it says there is no compiler. Cannot link with LSDC++. Interesting. Let's try installing something. lib std c++. Dev, I guess. No, then I guess we need to lib c++. Lib c++ mp17 dev, hopefully. No. Lib c++ 17 dev. And now it agrees. Okay, let's see if the compilation succeeds. Interesting. Could not find Python 3. Okay, let's install something like Python 3 dev. And then try again. Okay, so let's try installing libnuma, I guess. Libnuma dev. Yeah, now CMake configuration succeeded. So let's wait for the whole library to be built. Hopefully it shouldn't take much time. Let's install libhvlock dev. Now let's try to build. Yeah, now it seems to be building. Let's wait. And now the code is successfully compiled, so let's continue with the next steps. It says create virtual environment. Okay. Now it's downloading a lot of Python dependencies. Let's see how it goes. Okay, this step is done. We need to activate the environment. And it seems to be it. Okay. Now let's verify our installation. Python, run usage test. And it starts. Okay, so test seems to pass, which concludes our getting started tutorial. Please like and subscribe so you won't miss our next video, where we will run some actual large language models on this hardware and compare it to the NVIDIA GPU. Have a good day, see you soon!